Okay, we're going to try this question here, question 17 from the Sadler textbook. In this question it's to find that OA is equal to A, OB is equal to B. So there's the two vectors that we've defined. And then from there, we've already done these questions. Questions A to C, we're defining OC, AB, vector AB, vector AD, vector CD. So you can see those questions, they're kind of done just down here. So what we're going to do is we're going to have a go at question E, and we'll see how we go with that. Now with E it says if CE is equal to HCD and OE is equal to KOB, use the fact that OC plus CE, so this part here, just have a look at that, OC, so just the vector addition OC plus CE, and that'll be equal to OE. Now we're going to try and use that information to find the values of H and K. So there's H and there's K. Now if we have a bit of a look at it, the first thing to note is that because CE, this one here, CE, is equal to H times CD, just looking at it there, it looks like H might be equal to perhaps around about 2.5. And the K value, so OE is equal to some scalar multiple of OB. That looks like it might be perhaps equal to 2, just to give us a ballpark figure, and we'll go from there. Now we're going to use the fact that this part written in green here, if two vectors A and B are not parallel, and some scalar multiple lambda times vector A is equal to the other scalar multiple mu times vector B. If that's the case and those two vectors A and B are not parallel, then we can say that the two scalar multiples lambda and mu are in fact equal to 0. Okay, so what we'll do is we'll start off by writing out this vector addition in the question. So we'll just follow their prompts, OC plus CE equals OE. And then we're going to substitute in what we know. So first of all, OC, we've already found that that's equal to half A. And then CE is defined in the question as H times CD. So I'll put that in there. Also, OE is defined as K, some scalar multiple, times by vector OB. Now the whole idea here is we want to get all of this whole equation in terms of the vectors A and B, and then we're hoping to generate some sort of an expression that looks like this one up here, so that we can use this fact here to help us solve for the unknowns H and K. Okay, so in part D of the question, we had worked out what vector CD was equal to in terms of vectors A and B. So we'll go substitute that in. We'll get half A plus H times, so vector CD was negative 1/6 A plus 2/3 B. Same goes for vector OB. Vector OB is just in fact B, so that would be K times B. Okay, so we get to that point there, and now we're just going to go and do a bit of simplification here. And the idea is we want to get all of the vector A's onto one side of the equal sign, or the vector B's onto the other side of the equal sign. So we'll just tidy this up a little bit. We've got half times vector A, take 1/6 H times vector A, plus 2/3 H times vector B, so just expanding out that bracket, is equal to K times vector B. Okay, just trying to move that diagram. How do I move that around? Not sure if it's going to work. Doesn't matter. Okay, so from there I'm going to, just a little, I'm just going to move down here a bit. We've got a half times vector A, take 1/6 times H times vector A is equal to K times B, take 2/3 H times vector B. So I've now got all my vector A's on the left-hand side of the equation, all my vector B's on the right-hand side. We can then factorise those out, so the left-hand side will become vector A outside of a half, take 1/6 H. And taking vector B out of the right-hand side, we'll get vector B outside of K, take 2/3 H. And now we can see that we've got vector A times some scalar multiple. Let's call that lambda in here. So we got this part here is a scalar multiple in itself. We might call it lambda. This one here we might call mu. Now, because we do know that vector A and vector B, there's vector A there going that direction, vector B is over here, they're clearly non-parallel vectors. So because of that, these two scalars, lambda and mu, must both be equal to 0. That allows us to solve pretty easily. So we've got half take 1/6 h equals 0. We end up there with 1/6 h equals a half. And we'll get h is equal to 6/2, which is equal to 3. That one's done. And then coming from this bracket over here, mu must also be equal to 0. We've got k take 2/3 h equals 0. We've already worked out what h is equal to. So it's 2/3 times 3. H is equal to 3. We end up there with k take 2. The 3's cancel, equals 0. And k equals 2. There's our two solutions, h equals 3, k equals 2. If we go back to our initial estimate, we had h equals 2.5, k equals 2, we're in the ballpark, so we're thinking we're about right. And we're done.